actually begun to integrate the axiom of personality and the axiom of congruence into one unified axiom, which is the axiom of just personality itself, or gender congruence. So, in lieu of that, we're gonna discuss that. Gender congruence. And what is gender congruence exactly? What is this thing? And gender congruence is pretty self-evident in its meaning. So we have two words, gender and congruence. Gender is what a person identifies as. So it could be a guy or gal, gender role. While congruence, by nature, is something that is similar. So it's equivalent. So when we say that these two guys are congruent, they have roughly the same measure. So if we have a circle and we have two lines that connect the center and the circle cell, we would say A and B. We can say that A is congruent to B because by definition for radius, all radii of a circle are the same length. That's congruence. And when we say, now let's combine the two and say gender congruence, what do we mean by gender congruence? We mean not two genders being congruent or the same, but rather we're saying that the appearance, A, is equivalent to the condition, or the appearance is equal to the decision. A equals capital C and A equals small c. And so we can say that from here we can derive the equation that dA over dt is equal to dC over dt. And likewise, dA over dt equals dC over dt. Small c, big T, small c are not the same. So I just want to say that c is not equivalent to big C. And thus, their partial derivatives are not, their derivatives only are not the same, not equal. Okay? So, from there, actually, we can prove via congruence that dC dt minus d capital C over dt is equal to 0. This function here, this equation, holds via transitivity. Now I've given it to you guys as a homework, but I'm gonna derive the reason why they're like that here. Why? To transitivity, I also came with a proof here. Even though I said a while ago that they're not explicitly the same. Alright, so dA over dt is equivalent to dA over dt. We know that. That's true. So, and a while ago I stated that dA over dt is equal to d small c over dt, and that same thing, dA over dt, is equivalent to d capital C over dt. So the derivatives are the same and all that. And so from here we can conclude, since these guys are the same, these two, dA over dt is the same, see that dC over dt is equal to d small c over dt. Right. And so from there we can just move this to the other side and get this equation. So any function that that describes the decision, the confidence minus the inclination is equal to 0. So in notation here, O minus I equals 0. And if we package these two as functions or as variables, independent variables, and assign a third variable, let's say capital B to it, then the total differential of that function must equal 0 as well. So the Laplacian of that function equals 0. So assign a multivariable function to this. It's called b equals phi of c and capital C. Then the Laplacian of b is equal to 0. And Laplacian of which we're in the Laplacian of n just simply tells us to take the derivative with respect to small c plus the derivative with respect to partial derivative with respect to big C. And nabla n b is equal to d n b over d small c to the n plus d to the partial to the n b over d c capital C to the n. So we'll say that if we package these two into a multivariable function b, then that multivariable function b satisfies the equation nabla of n of b equals 0, where n is any integer. Arbitrary n, most likely just 1 to 3 or 1 to 2. N could be 1, 2, 3, mostly. We could plug in 6 there, or 7, as long as it's an integer, not an imaginary value, because saying we're taking the I partial derivative with respect to C makes no sense. I is the imaginary unit, -1. Unless you go to the complex world and get all that complexity, but we're talking about differential equations here. So there, if we package C and small c and take the C of B, total differential B described by the Laplacian of B, it would equal to 0. So it's Laplace's equation. It satisfies Laplace's equation. What else can we say about this? So package. Okay, no packaging. So back. What more can we say about this? That yeah, that's actually. And since AC, capital C with respect to T is equivalent to dA over dt, appearance is equivalent to the integral of dC over dt. That's that. Since dC is not part of t, this is actually 1 over dt, but actually it cancels out since it's an integral, so A is equal to C. So that's pretty neat how we prove it. So A is equal to the derivative of the integral of the derivative of C. And it cancels out, gives us A equals C. Another thing that I want to explicitly state that is that A appearance, the change in the appearance, what we previously called as the axiom of congruence. We've integrated this with the axiom of personality. Is that A is equal to A is equal to capital C. And since A is equal to capital C, we can say that A prime is equal to I, where I is the inclination, the derivative of C with respect to time. And A prime, the appearance with respect to time, is the variability. A. And we've actually, by saying that these two are equivalent to each other, I is equal to W, translate this to this side, I should say it around. W is equal to I. Translate this to the other side to get Y, W minus I equals 0. And there you have derived the variability inclination equation. So the variability minus the inclination equals 0, where inclination is simply the derivative rate change of the of the condition with respect to time. And these are actually very important equations in order to derive the flux W equation, which is the double derivative of the integral of Blackboard F, it's not F, Blackboard F dt squared is equivalent to the integral of W dt, where F is the flux, which I will discuss in another lecture. In fact, that's the next lecture actually, flux. So that's it for axiom of personality and axiom of congruence, which combine together into just the generalized axiom of personality or gender congruence. Congruence, which states that the appearance is equivalent or equal to small it's equal to the condition. Likewise, the appearance is equivalent to the decision. And right as well, from here we can say that C is equal to capital C. Ignore what I said a while ago that C is not equivalent to capital C. Don't you guys agree that when you feel like you want to be a girl, you decide to be a girl? Don't you guys agree that? Although they're not quotably the same, you can say that both of them are equivalent to each other. So it's going to put the third one over there to indicate equivalence, not direct equality, essentially. Equivalence. And so that's it for this lecture. The next lecture, flux, or rather behavioral flux. We're not talking about magnetic flux here, but rather just behavioral flux, the rate of change of the confidence with respect to time. So, I'll just provide a little example here, just so you guys get a better grasp of this. So, consider a trap that has an oscillatory. So we have a trap with this is an interval that's oscillatory in nature. This is T, male, female. Yep, oscillatory nature has a period of 2 pi or something. The derivative is tangent of the line. The derivative is this. So if this is C, this is dC over dt. So how he feels at that time frame, how he feels. For the machine that takes this C, it spits out, that lets us find the decision at any point. So if it's a positive derivative, that means that it's inclined to be a guy. If it's a negative derivative, it's inclined to be a gal. So there's that. And likewise, if we were to graph the C, same thing, right? And so the derivative is kind of same. Sine T equals sine T, which checks out sine, and their derivative is cosine. So cosine T equals cosine. And that checks out. This is a small example. Trap. So yeah, I'll see you guys in the next lecture.